let us get into some of the kind of the course logistics, right, and then the course style. Given that I have so far motivated the rationale for the course of working in a specific data science field, and then why particularly bioinformatics or computational biology. Let us get to some of the logistics and the style of the course, right. We will follow this active learning style, where we go in this particular format. So, each course section or each week, if you will, right, we have about 12 weeks or so in this whole course, right. So, each course section will invite student to think about an intriguing biomedical question. So, there will be a particular question that we will pose and you will think about it, and then iteratively formulate a computational problem addressing the questions. How do you cleanly, come up with a clear problem statement, a computational problem statement that in the language of computer science you can solve, right. So, converting all the intricacies of the biomedical problem, abstracting out the details and coming up with the core problem that will iteratively that will solve this or address this question. And once you have a clear problem statement, then you can choose a key algorithmic technique or a statistical model, like I said, dynamic programming or greedy algorithms or randomization in algorithms, evolutionary tree models, whatever, or certain machine learning models to solve the problem, right, whatever is the appropriate model to solve this particular problem, right, or the appropriate algorithmic solution for this problem. And finally, hopefully this whole exercise will also encourage you to think about open questions that students, you can think about, like as students you can think about algorithmically, right. So, we can even pose certain open questions, or you can come up with open questions that you can try to think about algorithmically, okay. And this may also be transferable in the sense that it may not necessarily be in this field, but then this whole exercise, does it also inspire you to think about some other question in another field that that currently occupies your mind, okay. And this kind of active learning style is we are going to closely follow this style that is in this reference textbook that we will be using for the course, Bioinformatics Algorithms by Philip Compo and Pavel Pevsner. And in fact, many of the slides later on we will also be using the instructor material that comes along with the book. So, these slides closely follow the book, and they are prepared in a way that it encourages this active learning style, okay. So, we thank Compo and Pevsner for agreeing to use the slides in this particular course. So, what are some of the expectations that in terms of prerequisites, right. So, in this program we have taken this course, programming data structures and algorithms using Python. So, that is what I see as the closest course in terms of prerequisites, right. In general, you would need to have some background in programming for some of the programming assignments and algorithms such as graph algorithms for addressing, for coming up with algorithmic solutions for some of these computational problems, right. And then though not required, recommended is machine learning techniques. This also you would have already seen by now. So, some of the questions that we will address will refer to using machine learning models, but mostly it will be about algorithms such as graph algorithms or algorithms on strings or algorithms on trees that we will be looking at. But some of them, some of the machine learning techniques like clustering will also be looked at. So, there are a majority would be on certain combinatorial algorithms like algorithms on graphs, strings and trees, and then others will be certain machine learning techniques such as clustering and related algorithms that we will be using. So, a knowledge of these algorithms and a recommended knowledge of certain machine learning techniques. Again, this is a course that you have already taken machine learning techniques. So, that would be sufficient for this course, right. And no knowledge of biology is required, all the biological concepts will be introduced then and there. In terms of my expectations, so those are formal prerequisites. So, in terms of expectations for the students, so this is an online medium. So, it has its own unique challenges and unique opportunities. There are various channels for active participation. So, I encourage you to actively use those channels. So, use the appropriate channels to ask or answer questions. And the idea is that the learning should not stop with this particular session or with the particular video recording. I hope to pique your curiosity on different concepts, and so that you can have discussions on other channels beyond these sessions. Okay. And one of the learning advice I have from Professor Manuel Blum. So, he is another eminent researcher, again a Turing Award winner. He has advised so many other graduate students who went on to become other eminent researchers themselves in the field of computer science, right. So, he has this nice set of advice that is collected in this page, and one of them is about how to read a book. So, you do not, I mean, typically the way we read a book is we start from the beginning, we all the way go chapter after chapter, and we go all the way till the end. So, but then Manuel Blum, he says that a book should be just opened up randomly, and then you should just look at a page in the book and then read whatever is in that page. If you do not understand, then you backtrack. If you understand, then you go forward, right. So, you do a random access on a book and then try to read a book that way. I mean, we know that in a computer, a random access memory, what power it gives you, right. And the reason I say this is same applies to learning a new topic such as biology also. So, you already have the prerequisites in terms of computer science as you are taking this course, but biology you will have to be learning different new concepts. But do not be intimidated by that. It is again like another analogy is like swimming. So, you just basically jump into the water and swim, and the another way of swimming is you just learn everything XYZ and then take all biology courses from very fundamentals to all the way, right. But we will be taking the former approach, we will be jumping into biology and then learning all the different concepts as and when we need them, right, and do not be intimidated by that. And the other thing is about, so that is about the background on biology, how we will be learning it, right, and the expectation is that you just catch on different concepts, we will not need a detailed understanding of biology. The other thing is, do you write or note take, right. There is this again Manuel Blum says about this difference between a finite automata and a Turing machine. So, for those who have studied computational complexity in computer science would know this, that a Turing machine is strictly more expressive than a finite automata, that it can compute any computable function, right. So, but the finite automata cannot, and the reason is that the Turing machine has a tape that it can write, right. So, that writing has a tremendous power to give you more expressivity. So, when you are listening to these sessions, one thing that I will encourage you to do is not just passively listen to these sessions, but actually take notes, because then you will be listening to the session, taking it in, and then synthesizing it in your mind on what is being taught, and then noting it down in your own words, right, and that has a huge power in learning the concepts better. So, that is another thing that I encourage you to actively note take or write when you are listening to these sessions. Even if it is a recording, whether you are doing it in the middle of the day or in the morning or in the night or whenever you are doing it, just have a paper and a pencil or a pen and do note taking. Okay. In summary, and then looking forward, life sciences is a fertile ground to practice data science, right. An associated field of bioinformatics or computational biology is well motivated from various perspectives, like I have shown now, and it offers opportunities to observe many impactful algorithms or models in action, right. So, like they are applied in these areas in order to practice algorithmic thinking. So, that is basically the idea we have for why we have this course in the first place on algorithmic thinking in bioinformatics is take a particular well motivated data science field, a specific data science field, and then see how algorithms are or models are in action in that field, right. The next steps would be choose an intriguing biomedical question, right, each week, and then think about how to solve it algorithmically, including its problem formulation. So, how do you go from the question to the problem, the algorithmic paradigms or model choices, how to go from problem to the solution to the algorithmic solution, and then the key data structures, right, like strings, trees or graphs that represent these different big data sets. Thank you for your attention, and the very next lecture would be about one of these intriguing biomedical questions, but before that we need to do a little bit of glossary of molecular biology terms. We will get to that in the next session. Yeah. Thanks for your attention.